Hello everyone. Today we'll continue with relativistic mechanics wherein we'll discuss briefly about Michelson Morley experiment, a very popular experiment to find the presence of an absolute frame of reference. Then we'll be moving forward with the Lorentz transformation equations. Michelson-Morley experiment was the most popular experiment performed in the year 1887, which was hovering around uh, to find the absolute frame of reference or the universal frame of reference called ether, with respect to which all the measurements are made. But the experimental result of this experiment disproved any existence of any absolute frame of reference or ether. So experimentally they could not find any ether basically. But there were several explanations given to this negative result. These explanations were very popular and they hold in fact the pillar of the special theory of relativity. So the theoretical assumptions were adjusted to match the experimental results, and that is how the special theory of relativity came up. So the very popular explanation of negative results in the Michelson-Morley experiment were: the first one was the principle of constancy of speed of light. The speed of light in free space has the same value in all inertial frame of reference. As you saw earlier also, this is the first postulate of special theory of relativity. Ether drag hypothesis. This was another hypothesis which was actually rejected due to the contradictory experimental phenomena like stellar aberration, etc. The most popular one, the explanation was Lorentz Fitzgerald contraction hypothesis, which said that all material bodies moving through ether get contracted by a factor of root of 1 minus v square by c square in their direction of motion only. Hence, the length of body in the direction of motion gets contracted by a factor of root of 1 minus v square by c square, given as L is equal to L naught root of 1 minus v square by c square, where L naught is the length of the body at rest, which is also termed as proper length. We will get into this very shortly in the topic length contraction. So Lorentz transformation equations were very popular equations because they were catering to the different velocities ranging from 0 to c. So if the speed of the frame S dash is v of the order of c, then these are the equations you have to consider. Or in fact, we can say Galilean transformation equations are a special case of Lorentz transformation equations, which you will see very soon. So these employ or satisfy the two postulates of special theory of relativity, unlike the Galilean transformation equations, where we saw that Galilean transformation equations violate the postulate of special theory of relativity, which was the postulate of constancy of speed of light. Also, Lorentz transformation equations satisfy the two postulates of special theory of relativity, which we'll see very shortly now, how these take care of the postulates also. So this is the same fashion as we defined the system in Galilean transformation equations also. When we were deriving those equations, let S and S dash be two inertial frames of reference. S dash is moving along plus x axis with uniform velocity v with respect to the stationary frame S. Let two observers O and O dash observe at any event P, say a flash of light emitted at t equal to t dash equal to 0. So at this point, the flash of light is emitted, which is taken as, which is called as some event P, whose coordinates with respect to S prime are x, y, z, t, and x dash, y dash, z dash, and t dash with respect to observer O dash in frame S dash. Okay, so the diagram remains same, just that we are calling the event to be flash of light now. So from the diagram, we can write the following equations. What Lorentz said is, instead of making x dash equal to x minus vt, let us introduce a proportionality factor called gamma here. So that is the main difference between Galilean and Lorentz transformation equations. So Lorentz said that let us find the value of this gamma which will define the further course of action. So he assumed x dash to be proportional to x minus vt, or x dash is equal to gamma times x minus vt. However, the other things remain same, y dash equal to y, z dash equal to z. Now, using the first postulate of special theory of relativity, which says that the laws of physics remain same in all inertial frame of reference. So if that is the case, then I can as well write, you see carefully here, these are the direct equations, primed quantities on the left hand side. Here I have unprimed quantity. This is the measurement done with respect to frame S. So now you have x dash gets converted to x. So I can as well write the entire equation as x equal to gamma x dash plus v t dash. Okay, so v has been replaced with minus v, t has been replaced with t dash. So this is from the first postulate. Now substituting for x dash from equation 1 into equation 2. So you have x is equal to gamma times gamma x minus vt plus vt dash. We can rearrange this entire equation and we get t dash. I want to find t dash, which comes out to be this equation number 3, which is gamma times t minus x by v 1 minus 1 by gamma square. Now please just see carefully here, t dash is seen to be not equal to t anymore. So this is my equation number 3. I've written in a red color. We'll be using this equation shortly. Now we use the second postulate of STOR, and we can write that distances traveled by event P with respect to x and x dash, with respect to s and s dash frames will be x is equal to ct and x dash equal to ct dash. Now this is entirely possible due to the consideration of second postulate of STOR, which says the principle of constancy of light. So you see carefully, I have not written c dash t dash here in x dash value. I have written both to be c, because the speed of light remains same with respect to all inertial frames of reference. Okay, so I have x equal to ct and x dash equal to ct dash. Substituting for x and x dash in 1 and 2, these values I am substituting back in equations 1 and 2. So I get ct dash is equal to gamma ct minus vt, which can also be written as gamma t times c minus v, equation number 4. And ct, which is from the equation 2, I can write x to be ct. So ct is equal to gamma ct dash plus vt dash, or gamma t dash c plus v, equation number 5. I multiply these two equations. Why? Because I need to find the value of gamma. So I have c square tt dash is equal to gamma square tt dash c square minus v square. So I rearrange, I get gamma is equal to c by root of c square minus v square. I can take out c from the denominator. This is square root of c square, so c will come out, it gets cancelled. So I have gamma is equal to 1 minus, this is 1 by root of 1 minus v square by c square. So that is what your equation number 6 is. So I have the value of gamma. Once I have the value of gamma, I can substitute back the gamma value from the equation number 6 into equations 1 and 3. We get x dash is equal to x minus vt by root of 1 minus v square by c square. Y dash and z dash remain same, and t dash becomes equal to gamma times t minus x by v brackets v square by c square. You have to substitute for gamma square here in this equation. So I get t dash to be gamma times t minus vx by c square, or t dash is equal to t minus vx by c square by root of 1 minus v square by c square. So that is how you see we have the new Lorentz transformation equations in terms of x dash, y dash, z dash and t dash. And if I know what are these equations, these are the direct equations, because you have primed quantities on the left hand side. So if I have to find inverse equations, how do I do that? Again, I change the sign and I replace v with minus v. So I have the new inverse Lorentz transform equations to be x equal to x dash plus vt dash by root of 1 minus v square by c square, y is equal to y dash, z equal to z dash, t is equal to t dash plus vx dash by c square by root of 1 minus v square by c square. What are the key points here in Lorentz transformation equations? First point is that t dash is no more equal to t. So that means in relativistic mechanics, when the velocity is of the order of the c, then it can be seen that t at the time is no more absolute. If I say time is no more absolute, then the measurements made by the S and S dash observers for the event will be quite different from each other. Okay, so that is why if T dash is not equal to T, then as well we can say that simultaneity of events also does not exist. That means T2 minus T1 is no more equal to T2 dash minus T1 dash if I take two events P1 and P2. Okay, that is what is meant by simultaneity of events. So we say that time is no more absolute when we increase the speed to the order of c. The second key point is Lorentz transformation equations reduced to Galilean equations at low velocities v far less than c. So that is also very easily seen here. From all these equations you can derive that Lorentz transformation equation will shrink down to uh, Galilean transformation equations for low velocities. That's all for today. Thank you everyone.